All right, welcome. Nice to see you all here. This is a 1-hour session. I won't speak for an hour. If you are still interested after around 30-40 minutes, we'll have an open discussion and hopefully there are a few questions that we can talk about. So I would like to start the presentation just getting to know you guys. So hands up if you have tried VR before. Good. It is approved. And how many of you have worked with or are working with VR right now? Good. That's a good amount of the people here. And is there anyone here that develops in VR? Okay, cool. So the topic of this session is to better understand what's required from a design perspective to make VR as powerful as it potentially can be. And my plan is to provide some perspective, and I'll do that for about 30-40 minutes, and then we'll have an open discussion. It was nice to see the previous speaker, Manuela. Are you still here? Oh, there you are. Nice talk. I have to agree with some of your findings, and I will also challenge a few of them. And also, it was nice to see a Gleechi video in the presentation. Cool. So Gleechi was founded in 2014 as a result from robotics research. So there were two of the co-founders doing PhDs. They were researching how to teach robots how to understand or dynamically determine how to interact with objects. So one of the big challenges back then, still today, is how to not need to reprogram every time a robot gets a new object to interact with. But in 2014, obviously, VR became quite hyped, and the algorithms and software that was starting to be developed at that point, we figured we could also use them in VR. So we're essentially just converted into VR. And today, Gleechi is a software product company. We're not doing hardware, not doing any kind of tracking, but just software development within VR. And we can get back to a little bit about what that is as well. We've worked with projects within healthcare, as was shown in the previous session a little bit, robotics, gaming, but right now we are focusing mostly on industry training, because that's essentially where we see the highest demand as well. I don't think I need to go into the details of why VR is important. It would be preaching to the choir, as you would say. But let's just talk a little bit about it and also get a little bit into why it is important or useful for not just the average IT or person, but also people with neurodivergent features like autism, ADHD, dyslexia, and so on. We'll talk a little bit about, excuse me, 4 main categories at Gleechi that we work with, and the importance of each and every one of them. And hopefully, in the end, you will get a cherry or two to bring with you when you go home. So, again, we don't need to go into the details of this, but when we meet people, and not people like you that already have it clear, most people think about gaming when they think about virtual reality. But it's so much more to it, we all know that, and it can put you essentially anywhere in any situation and start or allow you to start interacting with things that doesn't really exist. Compared to AR, of course, which is really useful as well, but more in a now moment where you have something that you can be helped with or you get instructions for and so on in the moment that you're in. Virtual reality can put you in, any type of situation. So one interesting thing as well is that virtual reality has proven to be a great challenger to traditional learning methodologies. There are different numbers floating around, but we usually refer to that it's around 15% more effective. I would say that is quite, what do you say, defensive numbers. Sometimes it's more, sometimes it's maybe less, but as we will get to, especially when it comes to the high-level training of people, it creates a lot more memory for us, you doing the experience in VR. But the main takeaway with VR, of course, is that it can add that immersive experience, which is something that cannot really be done in other mediums. So, and I mean, is there anyone here that have tried Rich's Plank? Expecting a lot of hands now? There are a few of you. So I mean, Rich's Plank, it's a simple game. You can download it at least before for free on Steam VR. You walk into an elevator, you go up to the top of the roof, and then you walk on a plank outside of the house. So you will see the street 15 floors down. Now, when I started working in the VR industry, I felt like there was a lot of talk about this immersiveness. And it's like, yeah, they're using it for sales, that's fine. But when you just try this game or example, you will understand. So if you haven't, please do so. Because when you are going out on that plank, even though you know you're in an office or wherever you are, your brain will start telling you that you shouldn't walk it, more or less. Some people are able to do it, but some people actually aren't. And a lot of the people that we meet wants to hold a hand or, you know, just look outside it and so on. So it's a really good example to really understand the immersive effect it can have on your brain. So there's a lot that we do at Gleechi. We'll primarily focus on these things today. And so let's start with interactions. In this category, I've just pointed out 3 different ones: movements, how we get to point A to point B within an experience; object interactions, how we interact with various objects, like Manuela also mentioned a bit. And also the user interface, so how we can allow the user to manipulate the environment on a more abstract level. That would be like set or get information within the application, such as step-by-step instructions and so on. So for movements, initially most of the movements were done with controllers, and while it looks good, it can oftentimes lead to motion sickness. And if you're not aware of the why this happens, it is essentially that if you're moving in real world and your character is not, or the opposite the way around, then you risk you can get motion sick. So one of the most common ways to avoid this today is the teleporting. And essentially you point to somewhere in the environment that you're in, and then you can release and you get teleported. That way you can avoid that motion and also the motion sickness. It doesn't require that much space. You can be in a pretty small spot, but still move around in a large area, which is good. And then you, of course, have the free movement or the spatial environments where you can actually, where you have the one-to-one mapping between your real-life movement to the avatar's movement in VR. I don't know if you've seen that example. It's just a picture, unfortunately. It's not a very good example of the free movement, but we've seen some interesting ways of tweaking it, because the free movement obviously requires a lot more space, right? But there was this one demo, I don't remember what the company was, but they created an Oculus Quest demo, and they mapped their quite small office to their application, one-to-one. But then they put elevators in each of the corners, so they can actually move up to the next level, which looked entirely different but it was still the same floor that they were walking. So they were like creating levels of it. So you can be smart about it as well. At Gleechi, we've created a number of different teleportation systems to allow newbie users to easily move. And in this example, the user is able to grasp and handle and pull herself to the point in the application. And while free teleportation, where you can select anywhere to go, is a common solution, we've noticed from our learnings, we've seen that people that don't have the gaming experience or the better technology experience sometimes struggle with it, especially older people, which might be good to know, depending on what you're developing. But by simplifying the teleportation to go to certain spots within the scene, you can also simplify the experience. And I think, as I will mention later as well, this is all about who you are targeting. If your target audience are gamers, then it's one thing. But if it isn't, then you need to be really smart about how you design things and keep it simple. Another example of simplicity, of course, is the hand controls. There are lots of buttons today that you can use. And I mean, gamers would probably want to use each and every one of them, learn how to do it in 2 hours, and then be as effective as possible in their performance. But when we're talking to, for example, workers in the industry, most of them, from our experience, don't have VR experience, and then of course, we need to do it as simple as possible, and most times it's just one button is enough to do most of what's needed. So object interactions, one of the most interesting things, in my opinion, as objects, of course, are essential in virtual reality. In real life, we use our hands thousands of times every day. I don't have the exact numbers. We're touching our faces like hundreds of times. Nowadays, we touch our mobile phones probably 1,000 times. We interact with doorknobs, cups, and all of the other stuff. But in VR, the challenge, as you are probably aware, is that even though we can design the objects really well, so they look super realistic, the interactions with them aren't really realistic. And what we've learned from our experience is that our brains actually intercepts the interaction with the objects even more important than how the object look. So we figured that if the user can use her own hands in a natural way or in the application, she will remember better. And the reason for this is that it generates less distraction and is perceived on a higher extent as if the user is doing these things herself. So even though the hands are virtual, the brain stores away some kind of muscle memory, if you can say that, I don't know, but it's a memory. And so in an area such as education, the interactions becomes crucial to help the attendees to learn better. Object interactions are part of our core technology, and we believe that it's going to be increasingly important to really make VR as powerful as it can be, and when it grows. So just want to show you a little example of VirtualGrasp that is part of our technology stack. In this example, the first part is going to be just interacting with objects in a way that you're probably used to see. And then the second one is like with VirtualGrasp, you'll see that the interaction is a little bit more realistic and natural. So like in many other examples, you often go like penetrate the object, and we call it the sticky grasp. while with VirtualGrasp you get more natural grasp, and the pinch grasp that Manala mentioned before as well. So, and if we look at that, was sort of like an example of that. I mean, this is another example from a training application for line assembly at one of our customers, as well as an emergency shutdown procedure. And just to give you a little bit more feeling about the VirtualGrasp and the object interactions. So while you're watching, I'll be talking as well. VirtualGrasp as a software is using complex machine learning and complex analysis based on machine learning to generate grasps based on the hand model, the object's mesh, and also the hand's position when you're approaching the object. There are plenty of different options with VirtualGrasp when you're using it, such as if you want the object to like snap into your hand, or if you want the hand to snap to the object, and also when you're interacting with things that might not be just loosely gravity-based, but that have joints. When you grasp stuff, you want to make sure that they move properly. So this is just kind of also part of that. And also, I mean, we've come pretty far on this, as I would say, at least compared to most other ones in the market. But it's so much more to it, because like you have the mesh, you have the hand, and then you have the position, and you can determine, the software can help you determine how to grasp it. But then, of course, you have the intention of the interaction as well. So if I want to drink from the cup, then I probably don't want to grasp it like this. If I want to put it in the dishwasher, I probably want to grab it from underneath and then to be able to put it properly. So this is also why it's important that you can also like add or remove the dynamically created grasps for different objects. Because you probably know best what the intention is. So VirtualGrasp is one of our core technologies. The other one that is worth mentioning, and that we'll also get back a little bit to in terms of research, is the pedagogical framework that we have created standardized and customizable instructions to help people learn better, including visual instruction, text-based instructions, or audio. So let's move on to user interface. When 3D games first appeared, it was common to simply convert 2D design into 3D and expect users to be happy about it. But most of them obviously didn't work very well. So in 3D or in virtual reality, they were kind of left out. One of the first attempts, I would say, to create a more robust user interface was the wristwatch or the tablet that you probably have seen a number of times, to like allow the user to manage the abstract information in the scene, such as step-by-step instructions and so on. But a user interface like this, of course, has a learning curve. So if you're approaching users that it's hopefully going to run this for 10 minutes every 6 months to keep up to date with what they know, maybe it's not the best way to do it. And so maybe context-based instructions are better. So context-based interface is another methodology where the users are guided to interact with the actual environment itself rather than an abstract watch or tablet. So if you're doing it right, because it's based on real life and experience and intuition, if you're doing it right, it will be more intuitive and people will more easily be able to not go through the same learning curve. And from what we have learned when it comes to user interface, in the same way as for instructions, is that it's important for the user to be able to set her own preferences, such as lighting and colors and so on, to feel as comfortable as she possibly can. So just to give you an example of a context-based user interface, in this case, the buttons on the lower right on the table are actual content in the scene and not on your wristwatch. And as a user, you're able to change the language, you're able to set the text size of the instructions, the brightness, you can reset the scene and start the instruction-based step-by-step guiding. All right, cool. So let's continue with environment. And in this section, we'll focus a little bit on realistic versus stylized environments and dig further into both of them. So let's start with realistic. Most people strive for realistic environments. If you got to choose, what would you prefer? Would you prefer realistic environments or stylized? Hands up for realistic. Okay, stylized. Oh, you're a good crowd. Okay, let's not jump into conclusions just yet. So, in our previous experience prior to this, we figured that people prefer realistic environments when asked. So, realism, when you are creating it, obviously it requires more resources from the hardware. And also, in many times, you would have to fake some parts of your application or crop some parts off. And if you're not careful with how users can interact with your environment, there is a risk that they can watch the beautiful house from the front side, but then if they are able to go around and you have not completed it fully on the back side, you know, they will be distracted and sort of get out from their immersion. And also, as mentioned in the questions on the last sessions, I think, the Uncanny Valley. How many people know about it? Good, that's most of you. If there is one that don't, this is sort of an illustration of it. So the emotional response from us as humans increases the more realistic something is, right? But at a certain stage, it drops drastically. And then you'd have to find out what's wrong with it. In this case, the humanoid roboter there, maybe Polar Express dude, I don't know. Okay. They are more realistic than Mr. Incredible, but it doesn't feel right. So you have to improve over that. So essentially that drop is what you want to avoid, which is, good to know. Stylized environments are simplified, less resource intense, and quicker to create. People express that they like it less. Not you guys, but other people. But what we've seen from our research and our experience is that people perform better in stylized environments. And one reason for this is that if the environment is simplified, the objects are more easily distinguished from the actual environments, so that the users are, it's easier for them to focus on what they're supposed to do. It's probably not a good example, but it's an extreme one. So Minecraft as an example, you probably know about it. It's super pixelated, super stylized, probably. If the Mojang people, the creators of Minecraft, would have asked their gaming audience when they started developing it if they wanted the realistic one or a stylized one, maybe they wouldn't have ended up with it. But the point is, in the stylized environment, it is also more forgiving. If you have a more stylized environment, the expectations on the rest of the experience is also lower. So it is easier to keep the user in the immersion throughout the scene. So when you're when you develop your applications or set up your own projects in VR, consider what hardware you're going to run it on. I mean, the performance of the hardware is increasing by the day, but at the same time, we have like Oculus Quest coming out with their new headset, and suddenly everyone wants it, and you cannot use the same resource-intense applications anymore. And also the target audience. If you are looking into teaching people, then given that people learn better in stylized environments, maybe it's a better idea to use stylized than realistic. Also ensure that, no, sorry, I've mentioned that. So an example of realistic versus stylized in the level that we see it, not the Minecraft level. This is a simple kitchen environment that we'll get back to a little bit later. And if you look at it, maybe it's a little bit hard to see here, but you know, there are small details everywhere. There are like patterns on the floor, the carpet, the table, and there are even dirt on the oven and so on. Then, if you consider this in terms of distinguishing objects from the environment and compare it to a stylized environment, it feels at least a bit more easier to see the different objects and kind of don't melt together as much. All right, so we did a research that I thought I would mention. We're not going to go into it as granular as Manuela's work, but if you're interested in the study, just reach out afterwards and we can provide more details. I've tried to summarize the key takeaways. The study was done together with a company called PTS in Sweden. They're like governmentally owned and sort of some kind of communicational, when communication for everyone is, they're kind of setting up frames for how to do things in a very standard way. I don't know really, but yeah, everyone knows who they are in Sweden. The study, however, it was performed with neurodivergent people, so and I mean, we might think that this is a small part of the population, but actually 1 out of 7 has some kind of neurodivergent features. So we're not like talking about the other people, we're talking about you or me or you or any of our colleagues. Even though we might haven't noticed the level of neurodivergent features isn't that high that we have noticed, but you know, it's amongst us. So in the study, we compared realism versus stylized environments, and we also compared 3 different instruction methods. So the audience was neurodiverse people, including dyslexia, ADHD, and autism spectra. There were about 30 people participating, and we were using 2 different scenes and 3 different instructions. We used the kitchen scene, as you saw previously, and we used the visual-based, text-based, and audio-based instructions. The tasks that they had were very simple. They were supposed to sort different fruits and vegetables. For example, put 3 bananas into some kind of basket and 2 tomatoes into the fridge. And if you would put 1 banana in the wrong place, it would count as an error, as an example. So every subject did 2 attempts each in various order, and the subject's performance was measured, and afterwards the subject also provided their own ratings on the environment, the difficulty, and the instructions, and so on. So on a high level, this was the results of the study, where most people preferred the realistic environment, but the stylized environment included less errors, and in the stylized environments, the difficulty level was rated as lower, as well as the instructions were rated higher. And within the instructions, visual instructions was rated as the preferred ones, but not all of the subjects thought that it was the best way for them, which was interesting. Text instructions generated least errors, and 84% of the audience thought that VR was a good way to learn. Cool. So when it comes to adoption, the VR market is still immature. I'm not sure if you agree with me, but outside of this group, I would say it is. We continuously need to focus on how VR can be more easily adopted. And there are a lot of things that are happening in favor of VR, such as lowered prices, more flexible solutions, and easier to get started. And nowadays, you don't even have to have computers and cables and so on. So that's great. But when you're running VR projects, being it for gaming, training, or other purposes, need to ensure that we include more people to get VR more adopted. People with and without disabilities, with low or non-technical or gaming skills since previous. I mean, the gamers, they won't have a problem to adopt anyway. And we're also required to think outside of the box. We can't rely on the historical solutions that were made in other scenarios and just apply it to VR. We need to think about it in a new way. We have just like started scratching the surface on how we can actually do things in a good way in VR. I mean, we also have like customers or partners approaching us, asking us to do something in VR, and can you do something in VR? And I mean, that's probably not the best way to start. Rather look at what you actually want to do. Sometimes VR can be measured to get you there, but you need to find out what the business case or if for a company is or so. It's like Henry Ford, right? The creator of the cars. If he would have asked people what they wanted, they would probably said faster horses and more beautiful wagons. We also need to ensure that, in our experience, interactions, texts, and movements allow different types of users to use it. And it is important to allow people to, as high extent as possible, to customize how they interact with the application. Colorblind people or people who are sensitive to noise also needs to be able to use VR. And sometimes we just throw in a bunch of props in our environments, objects in our environments, to like make it more realistic, while in fact it will just distract users more. So simplicity again. Some markets have already started seeing the value from VR, as mentioned. I mean, we're focusing on industry training, where companies can practice in dangerous environments or moments like scenarios that don't happen very often, or just try to lower their training costs by scaling it with VR. Medical solution have been mentioned a number of times, and there are lots of different solutions out there. Universities and high schools are increasingly interested in using VR for history lessons and physics, except, of course, apart from research. And in the military, it's also very common, where people can be put in a war scenario and actually be in that situation to learn or experience it before it actually happens. So if we go back a little bit to the richest Planck experience, imagine that you're working in a factory and there's this emergency procedure that you can do. You have an exact copy of the environment that you work in, and then you can practice the emergency procedure in that specific space. I mean, the alarms are sounding and the lights are swirling. You probably get a bit of pulse, at least, like to really practice under those specific, circumstances. And VR can put you there until you're truly prepared. This is the video from from the last session. And I mean, this is one of the most astonishing facts that we have learned when we were working with stroke rehabilitation together with Swedish hospitals to help stroke patients and the value that these people can get from VR. In the past, a common way of increasing the speed of rehabilitation for these patients was to have them looking into a mirror, where they're, oftentimes one part of the body was more or less disabled. If they were looking in the mirror, doing things with their functioning side, it would look like they were doing it with their disabled side. And it helped them because the brain saw their rights, for example, the right side doing things, and it actually increases the speed for them to rehabilitate. In this example that we worked on, we just amplified the movements of the stroke patients that had limited movements. And just by having the brain perceiving what's happening there, it actually helped them through the rehabilitation process and speeded up the actual process of healing again. I mean, I don't know what you think, but it's like magic for me, at least. It's super cool. All right, VR has proven to be a great solution or a great technology. Market is still immature. When we are attending to different events, not specifically this one maybe, but people oftentimes when they are trying demos out are astonished by what can be done in VR, because most of the guys just think about gaming. So to finish off and hopefully answer a few of your questions, I hope you feel the same as me. Virtual reality has a huge potential impact on training, gaming, or a lot of different areas. But we need to be responsible and thoughtful when we're creating our projects, all the way from the developers to the customers to the end users. These are just a few key points that I would say are important when you're doing your own projects. Is that, like, try and use stylized environment rather than inconsistent. If you're doing realistic, make sure it's consistent. Interaction realism is oftentimes more important than the design realism. Make sure to create inclusive and customizable solutions. And last thing is to keep it simple and keep the balance in your experience to allow more people into the ring. All right, cool. My name is David Svee. I work at Gleechi. Make sure to follow us on YouTube, LinkedIn, or any other social media that you can find us on. And I'm happy to take questions about VR, fishing, or golf.
Any questions to David? Thank you, David.